All right, guys, let's look at section 3.5, part A. We're going to cut this into two sections. Part B will be quite a bit harder than part A. So hopefully this part is stuff that you remember from Algebra 1 because you did cover it at some point in Algebra 1. All right, so some vocab. Parallel lines are two coplanar lines that never intersect. Okay, and as you remember from Algebra 1, or maybe even before, parallel lines have the same slope. All right, perpendicular lines, two lines that intersect at a 90-degree angle. And if you remember from Algebra 1, they have opposite reciprocals or negative reciprocals, whichever way you want to put it. Opposite reciprocals. Okay, now when I say opposite reciprocals, if one has the slope of 2, okay, you can think of 2 as just a 2 over 1. The opposite reciprocal, okay, so the opposite, if this is positive, the opposite would be negative, and the reciprocal, we're just going to flip the numerator and the denominator. So like 2 and negative 1/2 would be opposite reciprocals. So any line that has a slope of 2 and then another line that has a slope of negative 1/2 will be perpendicular wherever they intersect at. Directed line segment is a line segment with an additional property of direction. Okay, so it tells us what direction we're going in, and we'll get to that in the second part of section 5. All right, let's look at some of these lines. These are lines that are already graphed. So the ones on the left, as you can see, are parallel. The ones on the right are perpendicular. So remember, typically when we write the equation of a line, we write it in y equals mx plus b form. Now, each one of these says something. So the m is the slope. Okay, and if you remember, the slope is rise over run, or the change in y over change in x. You know, there's various ways you can learn this. And then the b is always our y-intercept. Okay, so it's where it crosses the y-axis. So if I look at C here, okay, it gives me the equation of this red line is y equals 1/2 x plus 2. Well, it tells us this line's parallel to it, so that means the start of this equation would be y equals 1/2 x, because we know the slopes have to be the same if it's parallel. Okay, now the number that goes at the end is where it crosses the y-axis. Okay, so it's right here. So it's 1, 2, 3. So it's at -3. So it'd be 1/2 x minus 3. This would be the equation of that line. All right, let's do D as an example for perpendicular. All right, so the first thing we want to do is we want to look at the slope. Okay, so if it's perpendicular, remember they have opposite reciprocals. So if the slope here is 1/2, the slope of the blue line would be its opposite reciprocal. So if this is positive, the opposite would be a negative, and the reciprocal of 1/2 is 2 over 1, which is just 2. So negative 2x, and then remember my plus b over here is where it crosses the y-axis, so it crosses right here at 1, so it'd be plus 1. Okay, now I want you to do E and F, try to do it on your own. I'm going to pause this and try to do it on your own, and then we'll come back and you can check your answers. All right, here are your answers for E and F. Now notice on E, it's parallel to, so the slope is going to stay the same. So notice we have a -2 and a -2. And then the number outside is just where it crosses the y-axis, so down here at -2, so we'd plug -2 in there. All right, now F, same but different. So we have a slope of -2, and we know that it is opposite reciprocal. So if this is negative, the slope of this would be a positive. And then the reciprocal of -2, we'll think of 2 over 1 would just be 1 over 2. So the slope here is positive 1/2. And then once again, outside is where it crosses the y-axis. Oop, and I messed up. This should be a plus 2. Nope, never mind. It should be a -2. I was looking at the red line, not the blue line. So it should be a -2 because we're looking at the blue line down here, -2. All right, guys, this is just where your book goes over the slopes of parallel lines and slopes of perpendicular lines. We've already talked about this. Just know that the slope of parallel lines, they have the same slope. Okay, like we've just been saying. And then here it says the products is -1. Well, that's the same thing as its opposite reciprocals. Because if you think opposite reciprocals A over B, the opposite reciprocal would be -B over A. And if you multiply these, well, the A and the A cancel out, B and the B cancel out, so it would just be product of -1. So it's the same thing as saying opposite reciprocals. All right, now let's go over A, and then I'll have you do a couple on your own, and then we'll go over some more together. So A, I want to find the equation of this line, of the blue line up here. Okay, so I know its y-intercept is at 3. So something plus 3 is going to be at the end. So now all I need to do is find the slope. So remember, slope is rise over run. And when I say rise over run, I mean up and down over left and right. So I'm going up 1 over 1, 2, 3. So my slope is 1/3. And remember, I need a variable. So the equation of line A would be y equals 1/3 x plus 3. Okay, I want you to do B and D. Those should be pretty easy. And then we'll come back and do C together. All right, guys, so I went and put what you should have got for lines B and D. Now, notice all I did is I counted the slope, and then I found the y-intercept and kind of put them together. So line C is a little bit different because notice we don't know where exactly they cross, okay? Right here, it's not on a solid number. So I'm going to do it a little bit differently. So we can still count that the slope is up 1 over 2. So the slope is still 2. Sorry, 1/2, up 1 over 2. Slope is 1/2. Now, I'm going to write this in point slope, or point slope form, Okay, so point slope form is y minus y1 equals m parentheses x minus x1. Okay, so your x1 and your y1 is just a point. It's a point on that line. Okay, and then your m is your slope. Okay, so I know my slope is 1/2. Now I can pick, do I want to use this 1, -4 or -1, -5 as my point? It doesn't matter. I'm just going to use 1, -4 as my point. So this is my x1, this is my y1. Okay, so I'm going to put it in this form right here. So y minus, let me change colors. So y minus, my y1 is -4. So minus a -4 is a +4. Equals my m, which is 1/2. X minus my x1 is a 1. Okay, so I can clean this up now. So y plus 4 equals 1/2 x minus 1/2. Okay, now I can subtract 3. So I get y equals 1/2 x minus 3.5. Okay, and that is the equation of this line. So y equals 1/2 x minus 3.5. All right, so it says which lines are parallel. Well, notice in order to be parallel, they have to have the same slope. So we have the same slope here and here. So lines B and C are parallel. So I'm going to say B is parallel to C. And then opposite reciprocal slopes. Well, isn't -2 and positive 1/2 opposite reciprocals? So I can say that line D is perpendicular to line C, and line D is also perpendicular to line B. All right, let's do another example here. So example 3 says write an equation of a line passing through the point 2, 3. So here's my x1 and my y1. That is perpendicular to this line. All right, when I look at this equation, I have to see that this is not in my y equals mx plus b form, which I want it to be. So I'm going to change it into y equals mx plus b. So 2x plus y equals 2. So if I subtract 2x from both sides, I get y equals negative 2x plus 2. Okay, now this and this are the same thing, just written differently. Okay, now that I have it in this form here, I can determine what I need the slope of the other line to be. Okay, so I want it perpendicular to this line. So here's the slope. So I want it to be the opposite reciprocal of negative 2. The slope of this new line is going to be the opposite reciprocal of negative 2. Okay, you can think of negative 2 the same thing as negative 2 over 1, if you'd like. So the opposite, so the negative would become a positive. And the reciprocal, I would flip the 2 and the 1. So the slope is going to be 1/2. That would be perpendicular to this one. And here's my x1 and y1. So once again, I have a point, I have a slope, so I'm going to use point slope form, which is y minus y1. Where'd my pen go? y1 equals, in parentheses, x minus x1. And then I'm just going to go and plug it in. So y minus my y1 is 3 equals, my m is 1/2, x minus my x1 is 2. So y minus 3 equals, I'm going to distribute this through 1/2 x minus 1 plus 3 plus 3. So y equals 1/2 x plus 2. This would be my answer. All right, let's do another one. Now this one's a lot easier because this is already in my slope-intercept form, which I like it. So we could very easily pull out my slope. So the slope of this line is 2. Okay, now I want to write an equation of a line that passes through this point. So here's my x1, my y1, that is parallel to this line. So you need to ask yourself, if you know it's parallel to this line, what does that tell you about the slope of what we want our new line to be? If it's parallel, that means we want the slopes to be the same. So this new line I have is going to have a slope of 2, and it's going to pass through this point. Okay, so once again, I have a point, and I have the slope, so I'm going to put it in point slope form. And once again, this is y minus y1 equals m x minus x1. Okay, well notice our m is 2. So y minus my y1 is 1. X minus my x1 is a -1, so minus a -1 is a +1. So I want to go through, just simplify. So y minus 1 equals, so I'm just going to distribute this through 2x plus 2. Add 1 to both sides. So y equals 2x plus 3. All right, guys, last but not least, here's our last example for this section, or this half section, I guess. What is the relationship between the lines y equals 4 and x equals 2? So here, it's very beneficial to plot this. So here's my coordinate grid. Here's my x-axis, here's my y-axis. Okay, so the line y equals 4 is going to pass through 4 on my y-axis. So this is y equals 4. That's what this line looks like. Okay, now the line x equals 2 is going to pass the number 2 on the x-axis. So it's going to look like this. Now, if you don't graph these, it's hard to see or to understand what the relationship is. But after you graph this, you can clearly see that these two lines are perpendicular. One is straight up and down, and one is straight across.